right, let's get started. Good morning, everybody. Hopefully you had a great weekend. Good. Today we're going to be talking about more applications of the fundamental theorem of calculus, which if you ever see me write FTC, that's my abbreviation for fundamental theorem of calculus. Okay. All right, so some announcements. You have homework due tonight. You're going to have a quiz tonight over what we learned today. Okay, so it's going to be due tonight. I'm going to open it after class, provided we get through everything we need to. Okay, so we'll open after class. Close parentheses. Okay, so any questions about these announcements? There's no homework posted because I'm not going to make you turn in something over Thanksgiving break. Okay, so instead of homework this week, I'm going to have, just so you know, I'm going to have short quizzes after each class every day. Okay, so that's what you can expect this week. All right, so any questions at all? Okay, so last time we stopped here. Ball is thrown into the air at 64 feet per second. What is the displacement? And that's the change in position of the ball between t equals 0 seconds and t equals 2 seconds. Okay, so let's look at a drawing real quick. I'm throwing this ball into the air and keeping track of how high the ball is in the air. Well, really, all I'm keeping track of is what's the difference in position between t equals 0 and t equals 2. Okay, so I don't know where I'm starting off throwing this ball. I could be standing on the ground and I throw it in the air, or I could be standing on top of the Empire State Building and I throw it up in the air. Okay, so but that's not going to make a difference in the end. Okay, so I start off somewhere. The ball starts at some height. Okay, I throw it into the air, it goes up, and then it goes down, and it hits the ground at some other time t. But t equals 2 might be in here somewhere. I want to find the difference between these two heights, right? I want to find the difference between those two heights, which is, I'm going to replace this y with an s because that's what we've been calling height for these types of problems. This is going to be s of 2 minus s of 0, right? The difference between those two y values, you just take the difference between the y values. Okay. So if I want to find s of 2 minus s of 0, there's a couple of things I could do. First, I could start off, well, no matter what I do, I'm going to have to start off with my acceleration as a function of time is, and anytime something is falling freely, we neglect wind resistance in this class. Again, if you want to see how wind resistance does affect a falling object, sign up for my numerical analysis class in the future, okay? It's a great class. You'll get to make all kinds of pictures and see what happens in more complex real-life situations. But today, we're going to pretend wind resistance isn't a thing, okay? And then the acceleration due to gravity is the only acceleration that we need to worry about. And for when we're using feet and seconds, then acceleration due to gravity is negative 32 feet per second squared. But what is acceleration? All of a sudden, this is a philosophy class. What is acceleration as related to either position or something else that this ball, some other property this ball has. It definitely has a height. What else does this ball? What else is it doing?
Change in velocity.
Yes, everyone said it. Velocity, right? Acceleration is the derivative of velocity. So that tells me v prime of t, v prime of t is a of t, right? So we know v prime of t is negative 32. So how do I get v of t then, knowing v prime of t is negative 32? Take an antiderivative, exactly right. So I'm going to say, well, I could integrate both sides. Take the indefinite integral, right? On the left, the indefinite integral of a derivative, I can just write down v of t on the left. On the right, the indefinite integral of negative 32 with respect to t is what?
Negative 32t.
Negative 32t. And remember, this is an indefinite integral, so what do I need?
Plus some constant.
Yes, plus some constant c. Okay. So, how do I find out what c is? What information did I give you? I have times, yeah. What else do we know? I'm trying to find something related to the velocity. Did I give you any information about the velocity? Or a velocity?
The ball's turned into the air 64 feet per second.
Good. I know that v, at the moment I throw this ball into the air, which is t equals 0, I know v of 0 is 64 feet per second. Okay. Well, also v of 0, when I plug 0 in on the right, I'm just left with c. So that tells me c has to just be 64, right? So I know that v as a function of t is equal to negative 32t plus 64. So that means what? How is velocity related to anything that we care about here? Because remember, we're trying to find displacement, which is just telling me the difference between two positions, right? I could go through and do the work to find the position function. In theory, I don't know my initial position, right? But you are right, that is related to position. How is velocity related to position? Exactly. V is equal to, V of t is equal to S prime of t, right? So, of course, I didn't give myself enough room. That means, well, we want to find S of 2 minus S of 0, right? This is what we want to find. How could I rewrite S of 2 minus S of 0? What does this look like? We talked a lot last week about a special theorem. This looks like what? Yes, thank you, Saba. It's the definite integral, right? This looks like the definite integral certainly from 0 to 2 of something, right? Of something. This is that net change theorem. So what are we integrating? If I end up with s of 2 minus s of 0, what did I integrate? Yeah, exactly. I integrated velocity. I integrated s prime of t. The integral of s prime of t is just s of t, right? So I don't even need to go through and find the actual position function. In particular, because I can't. I don't know how high the ball started off of the ground. So I can't say for sure what the position function is. But I can say for sure how far the ball went between the time t equals 0 and t equals 2, this displacement. Okay, so I need then to just integrate s prime of t between t equals 0 and t equals 2. Well, the integral from 0 to 2 of s prime of t dt, that's the integral of velocity. So that's the integral from 0 to 2 of negative 32t plus 64 dt, right? So this is then equal to, well, let's break it up as far as it can go. This is the integral from 0 to 2 of negative 32t dt. Anytime you're integrating a sum, you can break it up into a sum of integrals, okay? So negative 32t dt plus, ooh, that was an interesting thing, plus the integral from 0 to 2 of 64 dt. What should I do with that first integral?
Pull the negative 32 out to the front.
Yeah, anytime you have a constant times some function of t, you can pull that constant out in front of the integral. Okay, so this is negative 32 times the integral from 0 to 2 of t dt plus, and I can do the same thing here, 64. When I do that, I'm just left with 1 on the inside. So what's the integral from 0 to 2 of t with respect to t? Or at least what's an antiderivative of t? Because that's what we need. Yes, exactly. T squared over 2, right? This is the power rule for integration. It's the opposite of what we did when we differentiated. Instead of taking the exponent, putting it out in front of t, and then subtracting 1 from the exponent, we do the opposite thing. First, we add 1 to the exponent, and I divide by the new exponent. Okay, so this is negative 32 times t squared over 2. And I'm going to evaluate this in a second. Plus 64, what's the integral or an antiderivative of 1? Yeah, I mean, we're using t's here, but yeah, exactly. Plus 64 times t. I don't need plus c here because it's a definite integral. So then I evaluate this at t equals 2 and t equals 0. Okay, so when I do that, I'm gonna get, well, when t is 2, I'm gonna get negative 32 times 2 squared over 2. Well, 2 squared over 2 is just 2, right? So negative 32 times 2 plus 64 times 2. And then when I plug in 0, I get zeros everywhere, right? So minus 0. Okay, and so I'm gonna get then, well, I can pull the 2 out. 64 minus 32 is 32, so 32 times 2 is 64. I think I should get 64. Is that what everybody got? Did we put the bounds? Yeah, we put in the bounds separately and then took a difference. Exactly right. That's the fundamental theorem of calculus at work. Okay. So the displacement was 64 feet. Questions on this before we move on? So does that mean that the ball went up 64 feet? The ball went up 64 feet. It went up 60, but it definitely went up 64 feet total. I mean, in the end. But did it have to do it like this? No, it could have also done something like as long as this point minus that point, the y values differ by 64, then that gives us a displacement of 64. Okay, so you want to be careful that that's the difference between what's called displacement and total distance traveled. Okay, so with displacement between t equals a and t equals b, you're just looking at s of b minus s of a. If s is your position function, your displacement between two times is just your position at the end time minus the position at the beginning time. Okay? But when we say total distance traveled, we mean the distance traveled in, we'll say, the positive direction, the plus direction. So for the ball, the distance it traveled up plus the distance that it traveled down. Okay? Or in general, the negative direction. You might want to think of right and left as positive and negative for whatever reason. Okay? So it's possible that something can have a displacement of 0 when it moves, but have a total distance traveled of non-zero. And that happens all the time. When you guys left your house, pretend you just everything in your life is on a straight line. When you left your house to come here, well, your displacement is positive. But at the end of the day, when you go home, your displacement at the end of the day will be 0, right? You started and ended at home. But obviously you traveled back and forth. Your total distance traveled isn't 0, okay? So it happens almost every day for you. So to find the total distance traveled, we can just compute the integral from a to b of the absolute value of v of t. So the absolute value of v of t is called the speed sometimes. V is velocity. The absolute value of speed, or absolute value of v, is called speed. Okay. So if anyone ever asks what their speed is, you don't want to give them a direction. So let's look at an example. In the previous example, what is the total distance traveled by the ball between t equals 0 seconds and t equals 2 seconds? Okay. So now we're still starting with a of t is negative 32, and v of t, we already found v of t. V of t is negative 32t plus 64. Okay, so now I just need to check what is the integral, what is the integral from 0 to 2, not of just v of t, but the absolute value of v of t, dt. Okay. Well, the absolute value of v of t, we need to take a second and look at that. What absolute value of v of t looks like? Well, if negative 32t plus 64 is positive, then it's negative 32t plus 64, right? If negative 32t plus 64 is greater than 0. I mean, that's just the definition of the absolute value. The absolute value of a positive thing is just the thing itself. Okay? On the other hand, if negative 32t plus 64 is negative, then the absolute value of v of t is the negative of negative 32t plus 64. So I'll get 32t, so I take a negative, minus 64. So this is the negative of that top line. Okay. This is if negative 32t plus 64 is less than 0. So, although this is true, this doesn't help us very much yet, right? This doesn't help tell me how can I deal with this integral from 0 to 2 of the absolute value of v of t with respect to t. So what should I do in this up here, this function, this definition? Because this is all based on negative 32t plus 64. I would like for it to just be, I would like to know beforehand, if t is something, I'd like to know which line I'm plugging this into.
Solve for 0.
Uh,
Equal to 0.
yeah. I think you mean figure out where these guys are 0, right?
Yeah.
I need to solve those inequalities. That way I don't, given a t, I don't have to plug in into each line to see. I can just check, well, is t bigger than this one thing or is t less than that number, okay? So I need to look at when is negative 32t plus 64 greater than 0. Well, how do we solve inequalities? We just pretend the inequality is an equal sign for the most part. This part's gonna, this is gonna have, yes, thank you, Saba, you are correct. This part's gonna have a small hiccup that hopefully everybody remembers. So first thing I'm gonna do is subtract 64, minus 64. I get negative 32t is greater than negative 64. And then I divide both sides by negative 32. Divided by negative 32. Divided by negative 32. Okay, so then t, I have t on the left. Negative 64 divided by negative 32 is positive 2 on the right. And what does the inequality sign do?
It flips.
That's right. So I flip it. I have, if t is less than 2, then we are looking at the top line. Okay, so I'm going to come back up here and replace this. If t is less than 2. And if you go through and solve the other inequality, well, everything's the same, just the inequality is facing a different way. So this one's if t is greater than 2. So for this particular problem, the displacement between t equals 0 and t equals 2, it equals the total distance traveled between t equals 0 and t equals 2, because the absolute value of v of t on that time interval is just v of t. Okay, so we are looking at, let me add line. We are looking at the absolute value from 0 to 2, or sorry, that is different. The integral from 0 to 2 of the absolute value of v of t. This is equal to the integral from 0 to 2. Well, on the interval 0 to 2, that's t less than 0. I'm just using that top line, negative 32, negative 32t plus 64 with respect to t. Okay, and so we get the same answer we got before. Equals, if you go through and you crank out the numbers again, and if you want the extra practice, definitely do that. But we already know that this should give us 64 because we've done this integral before. Okay. Now, what if the question had asked, what is the total distance traveled between t equals 0 and t equals 3? What about total distance traveled between t equals 0 and t equals 3? What would change? Well, when we were looking at the total distance traveled between t equals 0 and t equals 2, we integrated the absolute value of v between t equals 0 and t equals 2. So what should I do instead if I'm looking for the total distance traveled between t equals 0 and t equals 3? Yes. Typically, we say bottom to top, but yes, exactly right. From 0 to 3 of absolute value of v of t dt. Okay. Exactly right. And now, how should I break this up? Because the absolute value of v of t changes on this interval, right? Between t equals 0 and t equals 2 is one thing, and then between t equals 2 and t equals 3 is another thing. So what should I do with this integral? Perfect. Exactly right. Exactly right. This is the integral from 0 to 2 of absolute value of v of t with respect to t plus the integral from 2 to 3 of the absolute value of v of t. And now on each of these smaller intervals, 0 to 2, I know exactly what's happening with absolute value of v of t. And from 2 to 3, I know what's happening with the absolute value of v of t. Okay, so this is going to be then the integral from 0 to 2. On this interval, the absolute value of v of t is just negative 32t plus 64 dt, plus the integral from 2 to 3. On this interval, the absolute value of v of t is the negative of the velocity. So it's 32t minus 64 dt. Okay. One more page. So then, this, again, we've already done that first integral. We've done it twice now. Well, I guess we've done it once, and then I used it a second time, and now I'm using it a third time. We know that this first integral is 64. We've found that 2 times ago. Okay, so really the only thing we need to do is evaluate this integral here. Okay, so when I do that, I'm going to get the integral from 2 to 3 of 32t minus 64 dt. Well, same numbers, practically the same function, so I'll just skip ahead. This is 32t squared over 2 minus 64t evaluated at t equals 3 and t equals 2. Okay. Questions? Where did I get t equals 3? That's a good question. I just came up with t equals 3. Yeah, good question. This is just what if the question had been, instead of total distance traveled between t equals 0 and t equals 2, what if it had been t equals 0 to t equals 3? Okay. So then I plug in, I get 32 times 9 divided by 2, 9 is 3 squared, minus 64 times 3, okay, and then minus 32 times 4 divided by 2 minus 64 times 2. Okay, so this comes out to be 16 times 9 minus 64 times 3 minus, well, we'll say, oops, we'll say 32 times 2 plus 64 times 2. Okay, and when we work smarter, not harder, and let our calculator do that, we get 16 times 9 minus 64 times 3 minus 32 times 2 plus 64 times 2. We get 16 for that. Okay. So on that second time interval between t equals 2 and t equals 3, we found that this ball traveled 16 feet. So what's the total distance traveled between t equals 0 and t equals 3?
80
Yes.
feet.
How'd you get 80?
You add 64 and 16.
Good. Don't forget that we had back here already this 64 from the first 2 seconds, and then now 16 from the second part of this interval, okay? So we're going to get total distance traveled is 64 plus 16, which is equal to 80 feet. Okay? Excellent. Any questions on that? All right, so let's look at some other applications of the fundamental theorem of calculus. So we're going to look at the mean value theorem for integrals. We know that knowing our velocity at any time t is very useful, but it's also sometimes important to know your average velocity. A lot of the time, what you care about is your average velocity over a trip. You know, if you're a runner, which I am not, you care about not your instantaneous velocity at every moment, right? I mean, that's important to know in the moment so you can pick up your pace, I guess. But what you really care about is how long did it take me to run this entire course, right? Well, how long did it take me to run a certain distance? That's an average velocity over your whole trip. Okay, so average velocity is very important to us in daily life. This average velocity, like I said, again, if you're a runner, you take this is your displacement, S of B minus S of A, and you divide it by B minus A, and if B and A are times, then this is the length of that time interval, right? But notice S of B minus S of A, again, by the fundamental theorem of calculus, is the integral from A to B of S prime of t dt. This is S of B minus S of A. Okay. But then S prime, we know that that is the integral from A to B of V of t dt. Okay. So notice that written out that way, if I write it like this, I should really have t's here. It doesn't actually matter because it's a dummy variable, but I would prefer to have t's there because these are functions of time. But notice that I can, just by rewriting S of B minus S of A that way, I can calculate my average value of V using only V, which is not something we could do in the past. To calculate the average velocity, you needed the position function. You needed how far did I go divided by how long did it take. Now, using just rewriting things in a special way, I can just say, well, I can integrate my velocity function. If I know my velocity at every time, I can say what my average velocity was. Okay. So this is essentially all the mean value theorem for integrals says. Okay. So we know by the mean value theorem for derivatives there's actually some number C between A and B, so that V of C is equal to that average value, right? The mean value theorem for derivatives said, well, if I'm looking here, if I'm looking at that, S of B minus S of A divided by B minus A, this is just the right-hand side of the mean value theorem. So that said that there is some C between A and B, so that S prime of C is equal to that, right? But again, S prime of C is just V. So that means there's some C, so that V of C is equal to this thing, which is just the average velocity. So this is really telling us that there's some number C between A and B, so that the integral from A to B of V, and pretend those are T's, is equal to the velocity at some C times the length of the interval. Okay, and really what this is, let me pull up something really quick. A picture of what's happening. I don't think I put a picture in this. Go image, and then week 13 banner. Okay, so here is an image. If I share this, here is an image of what the mean value theorem for integrals is really saying. It's saying if you have this blue area, so that's the integral from A to B under the blue curve, okay, then there's some number C, and for us that C is this number. It looks like it's maybe 0.06 maybe, but there's some number C between, in this instance it's between 0 and 1, so that the area underneath just the line y equals this function evaluated at C, the area under just that line is equal to the area under the curve. Okay? So the blue area is equal to this orange area. That's what the mean value theorem says. I had a professor when I was an undergrad who called it the mashed potato theorem. No matter how your mashed potatoes at Thanksgiving, very fitting, no matter how your mashed potatoes are on your plate, you can always sort of level them off, right? You can always get yourself a weird rectangle box of mashed potatoes, right? And that's all this is saying, is that you can just sort of fill in the gaps and level off the mountains so that you get just this nice rectangular picture here. That's all the mean value theorem for integrals is saying. So let me switch back. So this was illustrated with velocity and position, but it's true for any given function, okay? So the mean value theorem for integrals says if f is a continuous function on the interval a to b, then there exists some number c in the interval a to b such that the integral from a to b of f of x is equal to f of c times b minus a. Okay. The fact that this c is between a and b is kind of the special part of this, but it essentially just falls out from the mean value theorem for derivatives if you just rewrite the f of b. Here you would find an antiderivative and say f of b minus f of a over b minus a. I mean, that's really all this is saying. It's just a rewording of the mean value theorem for derivatives. Now, why is this a little better than the mean value theorem for derivatives? Well, the mean value theorem for derivatives required this f to be not continuous, but differentiable, which is it's harder for a function to be differentiable than it is for a function to be smooth. There are more continuous functions, or sorry, it's harder for a function to be differentiable than it is for it to be continuous. There's more continuous functions than there are differentiable functions. Okay, and so anytime we can take some theorem and reword it in terms of integrals, like the mean value theorem, that's a plus because then we can use it on a wider range of functions. And that's kind of the real power here. So, any questions on this? All right. It makes sense to define then the average value of a continuous function as this number that we saw. If I come back here, if I divide both sides of this by b minus a, then the left-hand side, it makes sense to call that the average value of a function. Okay. So that's all that we do here. We've defined the average value of a function to be the integral from a to b of f of x, and then divide it by the length of the interval. So any questions about why this is the definition of the average value of a function? And again, for me, thinking about velocity and position really helps to solidify why this is what we're calling the average value of a function. Okay. So let's look at an example. The quiz is almost entirely examples like this. Okay, so find the average value of the function f of x equals 3x squared minus 2x on the interval 1 to 4. Okay, so coming back here, the average value of a function on an interval, well, first you take the integral of the function over that interval. So I'm going to find the integral from 1 to 4 of the function 3x squared minus 2x with respect to x. But then if I want the average value of the function on this interval, what do I need to divide this by?
3.
3, which is 4 minus 1. Exactly. So I need to multiply by, or divide by, however you want to think of it, 1 over 4 minus 1. Okay? So, that makes more sense. There we go. So we have, this is it. I mean, we're done. We just need to, this is technically an answer, although it won't get you very far in the quiz. So I need to now actually do this integration. So I'm going to get 1/3 out in front times, well, we can break this up into its individual pieces. So this is the integral from 1 to 4 of 3x squared dx plus the integral from 1 to 4 of minus 2x dx. Well, I'll let you write that down. Okay. And then I can pull this 3 out in front, which I'm going to do. And I can pull this minus 2 out in front, which I'm going to do. So when I do that, I'm going to get 1/3 times 3 times what's it? An antiderivative of x squared?
X cubed over 3.
Cubed over 3, perfect. And then minus 2 times what's an antiderivative of x? Perfect, x squared over 2. Okay, so that cancels with that cancels with that, and I'm evaluating this at x equals 4 and x equals 1, and taking a difference. Okay, so I'm going to get, this is equal to 1/3 times x cubed minus x squared, again at x equals 4 and x equals 1. So 1/3 times 4 cubed is 64 minus 4 squared is 16. And then minus, you can keep the 1/3 out in front the whole time. I would keep that 1/3 out in front and only consider plugging into this thing. Or you could distribute the 1/3 if you want. I just always find that to be a little more messy than it needs to be. Okay, so then minus, when I plug in 1, I'm going to get 1 minus 1. Okay, so this part is 0. 64 minus 16 is 48. So this is 1/3 times 48. Which is what, 16? So the average value of this function on the interval 1 to 4 is 16. Questions on this? So if I ask about the average value of a function, it really, all I'm asking is integrate this function on this interval and divide by the length of the interval. Okay, it's just adding one small thing to an integral. So this is the last type of question you'll need to do on the quiz. Find the number c guaranteed by the mean value theorem for integrals where the function f of x equals x cubed on the interval 0 to 1. So as a reminder, the mean value theorem for integrals says, in this particular case, that the integral from 0 to 1 of f of x dx, well, f of x is, well, I'll put that in a second, that this is equal to f of c for some c between 0 and 1 times 1 minus 0. So that means I need to solve the equation plugging in our particular f. I need the integral from 0 to 1 of x cubed dx. This is equal to f of c for some c. Okay, well, f of c is just c cubed. Okay, so I need to solve this. The thing on the left is just a number. So I need to find that number, and then I'll just be able to take a cubed root. But do not try to take a cubed root first and think that it will cancel with this cube. No. The thing on the left, you have to do the whole integral on the left first. You can't bring operations into the integral like that.
How did you get c cubed?
C cubed is f of c. So when I take the integral on the left, well, what's an antiderivative of x cubed?
X to the 4 over 4.
Good. I'm going to get x to the 4 over 4. Evaluate at x equals 1, x equals 0. And so that just gives me the left-hand side is 1/4. So I want to solve the equation. I haven't done anything to the right-hand side. So I want to solve the equation 1/4 equals c cubed. Well, I mean, what solution does that have to have? Just c is equal to 1/4 to the 1/3, right? Very good. So, but you can only do that after you take the integral. Again, don't think you can start off and take the cubed root and then only take the integral of x. That's not how it works. Yeah.
For like a different problem, if it wasn't between 1 and 0, you would have multiplied
Yes, we would have, if this was on the interval from 0 to 2, for instance, you would multiply both the right-hand side by 2. There would be a 2 minus 0 there. Yeah. Very good. Yeah, technically that 1 is still, that 1 minus 0 is still there. All right. Do we have any questions for me? The rest of this is more of the same. The quiz is this. Okay, so you guys have everything you need to do to be able to do the quiz. So I'm gonna unlock that after class. If you have any questions about it, email me. I'll help you out. No worries, low stakes. But make sure to get it done before before midnight. Okay. So thank you all for being here. I'll see everybody tomorrow. Please write down your desks as you go.